Hello, my name is Christian, and this is Polynomials Major Assignment 3 and 4. So here I have recorded the equation h of x, which is 12x to the fourth plus 53x to the third plus 66x squared plus 12x minus 8. I need to find the roots, so here I started with the possible rational roots equation. Possible rational roots is equal to plus or minus the factors of the constant divided by the factors of the leading coefficient, which is equal to plus or minus 1, 2, 4, 8, 1/2, 1/3, 2/3, 4/3, 8/3, 1/6, and 1/12. And in order to get at least one rational root, I have to test them. So, for the first test, I started with -4. I replicated the coefficients of h of x into the synthetic division problem, and I dropped down to 12, multiplied that by -4, and I got -48. So 53 minus 48 equals 5. 5 times -4 is -20, so I put that up there. 66 minus 20 is 46. I multiplied that by -4. I got negative 184. 12 minus negative 184 gives you negative 172. If you multiply negative 172 by -4, you get positive 688. When you subtract 8 from that, you get a positive 608. But yeah, I was pretty much done with that by that point. So then I decided to try -1. So -1, drop down to 12. -1 times 12 gives you -12. 53 minus 12 gives you 41. 41 times -1 gives you 66 minus 41, which gives you 25. Multiply that by -1, you get a -25, so 12 minus 25 gives you a -13, and then you multiply that -13 by -1, and you get a positive 13, and -8 plus positive 13 gives you 5. So I got a bonus coordinate. Hooray! So I figured it must be less than -1, or technically more than -1. So I decided to start with a fraction. I started with -1/3, same deal. -1/3 times 12 gives you -4. 53 minus 4 gives you 49. Came down a line, multiply it again, you get 66 minus 49/3, and then you get 149/3. Apply that by -1/3, and you get a -149. Add 12 to that, you get -137, and then multiply -1/3 times -137, you get positive 411. Subtract 8 from that, you get 403. Now I'll show you what I got correct. When I finally did, it was -2/3. Because if you multiply that by 12, you get -8. Subtract 8 from 53, you get 45. 45 by -2/3, you get -30. And then you subtract 30 from 66, you get 36. And then multiply that by -2/3, and you get -24. Add 12 to -24, you get -12. And then you multiply -12 by negative 2/3, and you get positive 8. Add positive 8 to negative 8, you get 0, which means that your first term is x plus 2/3. That's your first factor. So now that you have the first factor, make h of x equals 0, so 0 equals 12x to the 4th plus 53x cubed plus 66x squared plus 12x minus 8. Then you just apply your factors in. So what you get along with that remainder of 0, you get a quotient of 12x cubed plus 45x squared plus 36x minus 12 times the factor of x plus 2/3. So I noticed that I could actually factor out a 3 from that whole thing, make my life easier, and so I did. And that left me with 4x cubed plus 15x squared plus 12x minus 4 times x plus 2/3. So I did the possible rational roots test again, plus or minus the factors of the constant divided by the factors of leading coefficient, which just gives you 1, 2, and 4 divided by 1, 2, and 4, which gives you plus or minus 1, 2, 4, 1/2, and 1/4. So now you just had to repeat the test again. So now to do the test again, you just take the quotient that you had, which you reconverted into a polynomial, and you redo the test with those coefficients. So I started the test with -1. So -1 times 4 is -4, 15 minus 4 is 11, -1 times 11 gives you -11, 12 minus 11 gives you 1, -1 times 1 gives you -1, -4 minus 1 gives you -5. So I knew that there wasn't going to be a factor of that -5 is definitely not a number on that line. Try it again with -1/2 because it seemed to be pretty close. So -1/2 times 4 gives you a -2. 15 minus 2 gives you 13. 13 times -1/2 gives you -13 halves. 12 minus 13 halves gives you 11 halves. That's because you set that 12 and make it convert it into a fraction with a common denominator of halves. You have to multiply that 12 by 2. So that gives you 24. 24 halves. So you've converted that whole number into a fraction. And then you just subtract. So 24 halves minus 13 halves gives you 11 halves. 11 halves times -1 halves gives you -11 fourths, and then -4, you just do the same thing, convert that whole number into a fraction with the common denominator of 4. So that gives you -16 over 4. So -16 over 4 minus -11 gives you a -27 fourths. That obviously didn't work, so we're done. And I did the test with -2. -2 times 4 gives you -8. 15 minus 8 is 7. 7 times -2 is -14. 12 minus 14 is -2. -2 times the -2 gives you a +4. -4 plus +4 gives you 0. Hooray! We've done synthetic division again, which gives us the factor of x plus 2. So now you can just take the new quotient which you have, which is 4x squared plus 7x minus 2 times x plus 2 times x plus 2/3, and set that to equal 0. And now you can just actually factor, or at least try to factor, the quotient that you had left over, the new quadratic polynomial that you have. So doing the AC method, you have a negative 8, so negative 1 times 8 gives you not only negative 8, but it also gives you, you add them together, it gives you 7x. You actually, so now you can just split them up, so now you have 4x squared plus 8x minus x. You don't actually have to write 1x, and that'll give you, minus 2. Factor it out. Notice that the greatest common factor between 4x squared and 8x is 4x, so I factored that out. That left me with x plus 2. And then I just wrote down x plus 2 and figured out what I'd have to multiply x plus 2 with to be able to get negative x minus 2. And it would just be a negative 1. So now I have all the factors that I need, and lo and behold, you have double roots. Hooray! So I recombined that, just moved on, set all of that to 0 again, but with the change that I put x plus 2, I put that factor to the power of 2, since it's just that easy, and then I added little exponents of 1 to the other factors, so I know that they don't bounce, they don't touch and turn back, that they actually cross the x-axis at those points. But I still have a factor here, 4x minus 1, that needs to be, I need to determine what the coordinate would be, so I set that factor to 0, add 1 to both sides, then I divide both sides by 4, which leaves me with a positive 1/4 as an x-intercept. So I just write down the x-intercepts as 1 over 4 equals x, negative 2 equals x, which there are 2 of those. I just put a double root, which shows me that it bounces. Then you have negative 2/3 equals x. Anyway, so you have 4 roots are confirmed. I expected 4 roots because leading term test determined, because the exponent had, it was to the power of 4, I expected 4 roots, and I got 4 roots. Wonderful. With a double root. And then the y-intercept is pretty easy. It's just that constant, so it's a negative 8, so I know that the graph is going to intercept at 0, negative 8. And then the x-intercepts I knew would be negative 2, 0, negative 2/3, 0, and positive 1/4, 0. The leading term test determined that because the leading coefficient is positive, it will rise to the right. The graph will. And the exponent is even to 4, so I know that it will also rise to the left. And as I stated earlier, I expected 4 roots, we got 4 roots. It will have 3 turns, or at least that's what we expect. And there will be 1 bounce because of the multiplicity. So now it comes time to graph the equation. H of x equals 12x to the 4th plus 53x cubed plus 66x squared plus 12x minus 8. And as you can see here, we get everything that we need. There's h of x, it's graphed. The left and the right side, they rise. The left side rises to the left, right side rises to the right. Cool. So here's a whole graph. There you have h of x right there. And then you have one bonus point, negative 1, 5. Then you have the x-intercepts right where they should be. So there's negative 2. And then there's one right before where that 1 is. So it's at negative 2/3. And then there's the other one at positive 1/4. All at 0, of course. And then you have the y-intercept, which is at 0, negative 8. And that's it. Thank you for listening to me and watching this work. Please forgive my mistakes. Mr. Leach, it is all yours. Thank you. This was actually kind of fun.